poisoning is one of the most lethal poisons known to man. Cyanide poisoning can be difficult to detect. The effects of cyanide ingestion are very similar to the effects of suffocation, because cyanide stops the cells of the body from being able to use oxygen, which all cells need to survive. The symptoms of cyanide poisoning are similar to those experienced when hiking or climbing at high altitudes. There are many symptoms to cyanide poisoning: general weakness, confusion, bizarre behavior, excessive sleepiness, coma, shortness of breath, headache, dizziness, and seizures can all be present with cyanide poisoning. Typically, an acute ingestion will have a dramatic, rapid onset, immediately affecting the heart and causing sudden collapse. It can also immediately affect the brain and cause a seizure or coma. Chronic poisoning over a long period of time from ingestion or environmental poisoning will have a more gradual onset. The skin of a cyanide poisoned person can sometimes be unusually pink, or not just red, but cherry red, because oxygen will stay in the blood and not get into the cells. The person may also breathe very fast and have either a very fast or a very slow heartbeat. Sometimes the person's breath can smell like bitter almonds, though this can be difficult to detect. Cyanide acts almost instantly, and only a small amount is needed for a lethal dose. The average fatal dose is only 50 or 60 milligrams. Cyanide is used as a gaseous hydrogen cyanide and as solid salts, which contain the cyanide ions. The gas is used for extermination of insects and rodents in ships, warehouses, and railway cars, and on certain fruit trees.
There are many known antidotes for cyanide poisoning. The most recent is when hydroxycobamine reacts with cyanide to form cyanocobamine, which can be eliminated by the kidneys. Using this method stops the forming of the methemoglobin, which competes with the cytochrome oxidase for the cyanide ion. That antidote is sold under the name cyanogen. An older method was the administration of 3 substances. One was the inhalation of amyl nitrate pearls and an injection of sodium nitrate and sodium thiosulfate. The goal of a cyanide antidote is to create a large amount of ferric iron. The ferric iron competes with the cytochrome, which is necessary for energy production of cyanide. There are also many forensic tests to detect cyanide. The first test is the Prussian blue test. Prussian blue iron 2 sulfate is added to the suspected solution. If the solution forms Prussian blue, it is a positive result for cyanide. The second test is the para-benzoquinine. This is added to the suspected solution, which reacts with cyanide to form cyanophonol, which is fluorescent. When this is illuminated by UV light, it gives off a greenish-blue glow, meaning it is positive. The third is the gas diffusion. The gas diffusion flow injection analysis is a sample of cyanide, which is injected into an acidic steam, where the hydrogen cyanide is formed and passes under a gas diffusion membrane that allows only hydrogen cyanide to pass through. The hydrogen cyanide that passes through is absorbed into a solution that transports the cyanide into a detector that measures cyanide concentrations.